Hello, okay, so welcome to this video. This is the second one on the series of vectors, and if you haven't seen the first one and you don't know what a vector is at all, then please go and watch it first. It's about 10-minute intro and it's really going to help with this one. So just a quick recap, vectors are a kind of new mathematical object that we haven't really come across so much, and being a new mathematical kind of object, it's got its own ways that you can add it, subtract it, ways of multiplying them, and the kind of results and what they mean. So we had a little bit of an intro in the last video regarding the general forms of a vector. And so one thing I forgot to mention was that there's two ways of annotating vectors. You either put an arrow on the top like this, which tells you that A is not a normal number, like a variable that represents just a pure number. It tells you that it's a vector. Or you can write the vectors like this, which I think is a bit quicker, just a line underlining them. That's how you write vectors, as opposed to normal variables. And remember that vectors have the special property that they not only have magnitude, but they also have a direction. So if you just have a number 5 there, that cannot refer to a vector. Similarly, if you just have a direction, east, that can also not refer to a vector. But if somebody tells you, hey, I am going at 5 kilometers per hour in a direction of east, now this whole packet of information is a vector. And it can be represented in a more effective way or more fast way with column form and horizontal form once you've defined what you mean by those directions. So I apologize, by the way, if, for the noise in the background. There's only so much time available, and so I'm kind of multitasking. I hope it's not too annoying. Okay, so let's move to the next thing. So you write them like this or like that. The two horizontal ways that you can actually define a vector, one of them was in this form. The general one was xi plus yj. Let's stick to 2 dimensions for now. And the column form was just x here and y there, where you don't have to draw I and j because it's specified by the position of the numbers. So I wanted here to explain a little bit about I and j and k in 3 dimensions, but here we only have I and j. What is I and what is j? Well, it's really important to know what they are, because they're kind of, it's kind of a new way of thinking about directions and things. I is basically, if this is your x-axis and this is your y-axis, change the tool, this is your y-axis, then I is a very special vector. It's called a unit vector. Unit vector pointing in the direction of x. So imagine that this is size 1. If that has the size of 1, then a vector which has a size of 1 and points in the direction of x, that vector we call I. It must have a size of 1. In other words, you can write it as a column vector like this. It has a size of 1 in the x direction and a size of 0 in the y direction. In other words, it doesn't point in that direction at all. Certainly not in this direction. It points purely in the direction of x. So that's I, and I made a mistake already. I hope you spotted it. I must draw a line underneath there to say that this is a vector, because otherwise it wouldn't make sense to say that there's a column vector here on the right and on the left I just have a variable. It cannot be. You can't just have x equals and then a column vector. This needs to be a vector too, and you indicate that by underlining it. So that's very important. I hope you can guess what j is going to be, if that's what I is, and j is the same thing over here, where this is a size of 1. Then we can say that j equals 0 in the x direction and 1 in the y direction. Why are these useful? Well, when you want to say a general vector over here. So imagine that there's a vector that points to that coordinate over there. Okay, and straight over here, there. Imagine that you have this vector over there, and we're going to call this vector B, so we don't always call it A. And we want to explain what that vector is. Well, we explained it in terms of multiples of i's and j's. So if this has a coordinate of 3, and over here has a coordinate of, I don't know, 5, then what do I need to get to this point here to express this kind of direction and magnitude? Well, I need how many i's and how many j's, and then I've split it into my two components. Is the other key word that I want you to get used to. Components. It tells me what the components in the I direction are, components in the j direction are. So there's 3 of these guys, 5 of those guys, so I can say that my vector B equals 3 units in the direction of my I vector and 5 units in the direction of my j vector. In other words, if I multiply my I vector by 3, I get this guy, right? That guy. It's not very well drawn, but you get the idea. Yeah, I get this guy. And if I add to that another vector that is actually 5 times the j vector, then I get this guy over here. But if you watch my previous video, you know that vectors can be shifted from one place to the other as long as they keep their direction property. So actually adding it on here is very similar to shifting it over here and adding it all the way here. This same vector that was over here, you can add it over here to the head of this vector over here, and we'll do adding of vectors more in detail later, but just to get you used to the idea, you can add it here, shift it on the right, and actually the B, which is the resultant of those two components, is kind of the hypotenuse of the triangle formed by these two sides, and this kind of relationship is going to really help us later on to calculate what happens when you add vectors. But the same as you can add a vector to another one to get a third vector, you can also split an original vector into two components, one of them being in the j direction, the other one being in the I direction. So you can split components into vectors into two components, or you can add two vectors to give you a resultant vector. All of that is possible. But I just wanted you to get the idea here that you can express a vector in terms of the i's and j components, and if you were in 3 dimensions, hopefully you can see that you get this kind of cube thing forming. I'm not very good at drawing in 3D, sorry about this. And if you get this cube happening, this kind of cube, you can, and that was the origin, and you wanted to describe this vector over there, then you would need 3 dimensions. You would need your I, you would need your j direction, and you would need your k direction there to express that in 3 dimensions. And in that case, you would have here an extra component. That is the k that tells you how much into the page or how much out of the page you're going, right? So you could have your k going into the page here. And it would show up here, and however many units you want to go in that direction to k. Okay, and the general form for this was then xi plus yj, where x is the size of the units, you know, the number that we're multiplying the i's by in the x direction, obviously, because that's the nature of I, and the y is the size of the number that we're multiplying by the j vector. But I also said, hopefully you can remember in the other video, that there was a quicker way to writing it, which is this column vector over here, which is, if I want to say all of that for B, I can just say that B is the vector whose x, you know, whose x coordinate or y, the x direction or the I direction has a magnitude of 3, and whose j direction has a magnitude of 5. So this represents the same thing as that, just 2 different ways of writing it. Okay, so now we know a little bit more about the I and the J's and what they're doing there, and I'll move on to the next video before I talk about the next thing, because I want to keep them around 10 minutes maximum long. Alright, see you in the next one.